Hello students, welcome to Educate. In this video, we will discuss about the very important topic, that is nomenclature of coordination compound. If you have watched the question bank of IIT and NEET as well as of 12th board examination, you must have realized that how much important this topic is. But here, there is rules, regulations of nomenclature of organic compound. But question will not ask what the rule there. Simply in the examination, question will be what will be the IUPAC name of that compound. Like there is rules here. What's the rules you will have to follow to write the formula of the coordination compound, and if formula is given, then what's the rule you will have to follow when you will have to write the IPAC nomenclature of the compound. Better here I shall tell you during solving these questions how to write the IPAC name, and then after you will practice them. You should then after you practice to a number of questions, and I hope if you will listen this nomenclature carefully, then you must solve those questions by yourself. Even though if problem you face there, then Educate is with you. Always Educate pleased to help you if you will consult them. Okay, so first of all, let's see here for this compound how to write the IUPAC name here. Okay, ammonia here. Okay, whenever you will have to write the IUPAC name, you will have to write firstly the name of cation, and then after the name of anion. Like you tell potassium chloride, you tell ferric oxide. So what is happening? You always write the name of cation. Firstly you write the name of cation, and then after the name of anion. So in the same way here, firstly you will have to write the name of cation and the name of anion. And let's see in this compound, this one here coordination sphere here till here. So whole this one is cation and anion is Cl minus. So obviously we write firstly the name of cation, then after the name of anion. Then after let's see how to write the name of this coordination sphere. So during the name writing the name of the coordination sphere, firstly you will have to write the name of ligand, and then after the name of central atom. Firstly you will have to write the name of ligand, and that will be in alphabetical order. And in the examination, the arrangement of ligand will be also according to alphabetical order. When you will have to write also, if name has been provided and it will ask what will be the formula of the compound, then also you will have to arrange the ligand according to their alphabetical order. So here first here is amine. So amine here we write AMMINE. Okay, and how much amine is 3? So we write triamine. So 3 amine is so tri, and there should be no gap between the name of ligand as well as between the name of ligand and the central metal atom. There will be no gap between the name of ligand as well as between the name of ligand and the central atom. But we will have to keep a gap between the name of cation and anion. When you write potassium chloride, so there will be a gap between potassium and chloride. When you write ferric oxide, then firstly you write ferric, and there will be a gap between ferric and oxide. So same way here, first there will be no gap between the name of ligand as well as between the name of ligand and the central atom. But a gap will be between the name of cation and anion. Cation is this coordination sphere. So that's why firstly we are writing the name of the coordination sphere. And here 3-amine ammonia is. So that's why we write triamine. Triamine written. Then after for water we use aqua. You know aqua. Aquaculture means aquaculture means we do something rares in water. That is aquaculture. So for water we write aqua. Okay. Firstly try this one. So that will be try aqua. Then after chromium, their oxidation number you have to write, and then after chloride. Okay, I am giving you 1 minute time. You find out the oxidation number of chromium. Okay, guys, calculated? Not. I think this one who have not studied well in the 11th class, he will not calculate. I am calculating. Listen, chromium, you don't know the oxidation number of chromium, you don't know. So write X for chromium. Ammonia is a neutral molecule. So oxidation number of neutral molecule is 0. So that's why 3 into 0 plus. Water is also a neutral molecule. So 3 into 0 plus. Then after this chlorine here 3 negative charge. So minus 3. That whole will be 0. So this 0 0. So x equal to 3. So here that will be x is equal to plus 3. So here we will have to write the oxidation number in Roman code. That is 3. Okay. Not difficult. Let's see the second question. Here this compound. So this coordination sphere is the cation and sulfate is the anion. And the ligand is here. This one ethane 1,2-diamine. Name is ethane 1,2-diamine. Okay, number has came here. In the name of the ligand, there is a number. So we will have to write bis on the place of di, tris on the place of tri, tetrakis on the place of 4. So here we write ethane 1,2-diamine and it is 2 here. Here, no, sorry, there is 3. So we will write here, that is inside the bracket, and that's why we will write tris. Firstly, we will write tris. Why tris? Because the number there is a number in the name of ligand. So that's why tris, ethane 1,2-diamine written. Then it is cobalt here. Might be visible, red color I am using. So visible here. Cobalt here, now, and here sulfate. Then after this cobalt here, its oxidation number, and here sulfate. How much counter ion there is? This one which is outside the bracket, that is called counter ion. How much counter ion is there, that you will not have to write. Okay, simply write sulfate. Okay, now watch out the oxidation number. Cobalt X plus ethane 1,2-diamine is a neutral molecule, so 0. That is here. And that is whole. So if sulfate will go from here, so one sulfate contain 2 negative charge. So 3 sulfate will contain 6 negative charge. So there will be 6 positive charge on this one. As a whole, there will be 6 positive charge, and the 6 positive charge will be balanced by 2 ammonia molecule. That means 6 positive charge will be here whole twice here. Watch out here carefully. There is whole twice. That means there is as a whole there will be 6 positive charge. So that will be divided by 2 portion. So plus 3 each. So cobalt will have here, this one is 0 oxidation number. So cobalt will have plus 3 oxidation state. So here 3. Okay guys, very simple here. Now let's see next. Let's see of this compound. Here is, so firstly watch out which one is cation and which one is anion. So here cation is this portion, anion is this portion. So firstly you will have to write this one, and so to write the cation, here cation is also coordination sphere and anion is also coordination sphere. So firstly write the name of the ligand. Ligand is amine, and here no number has came in the name of the ligand. So that's why we write simply diamine. So it will be diamine. It is silver, so silver. Diamine silver, their oxidation number you will have to write. And then after here is name of the ligand here, silver here. So if coordination sphere will be anion, then we will use the term suffix "ate", and the metal of which the English name and the Latin name is different. Then if that metal will be a part of cation, then we will use the English name, as I have used silver. And if that metal atom, the metal atom of which the English name and the Latin name is different, when that metal will be a part of anion, then we will use the Latin word and the suffix "ate" we will use. So silver here, that is argentinum. Latin name of silver is argentinum. So here we will remove by 8. So that will be argentate. Here. E and UM we replace by 8. So that will be called argentate. So here diamine, silver, their oxidation number, and here oxidation number will be divided by 2 portion here. Cn minus 2 units of positive charge. So here 2 silver here. So we will take 2x plus ammonia 2 into ammonia is a neutral molecule. So 0 plus here Cn is minus 2. So 2 into minus 1 that equal to 0. So x equal to how much? This one 0 to minus 2 here. So x equal to plus 1. So here plus 1. And that is the name of this one. So 2 cyanide group here is, so that's why we write dicyanide. So that's dicyanide, and then after argentinum. Oh, sorry, argentate. And their oxidation number you have find out. One is oxidation number. This one. Okay, easy. Now let's see how to write the IUPAC name of this compound. Here is, that is example this one and this one, but we discuss from here. Let's see. First compound here. This compound. So here cation is this one, anion is chloride. So firstly we will have to write the name of the coordination sphere, and during the writing the name of the coordination sphere, firstly we will have to write the name of ligand. So there is 4 ammonia. So we will write tetraamine. Then after is water. So aqua, or so tetraamine. So aqua here. And then after is chlorine. So chlorine. So we write chlorido. That's it. No gap between the ligand here. Okay. And then after between the central metal atom also not. So cobalt. their oxidation number, and then after how much chloride, that you will not have to mention, simply write chloride. So find out the oxidation number. Cobalt X, ammonia is here 0, here water is also 0, chlorine -1, and as a whole if 2 chlorine will go, so there will be +2. So here how much? This one 0, so X equal to 3 plus 3. So here 3, right here 3 in the Roman word. Then after here, so let's see. Cation is potassium and anion is whole this one. So here firstly we will write cation is potassium. So simply we will have to write potassium. We will not have to mention how much counter ion is there. We will have to simply write the name of the counter ion. That means counter ion means cation or the anion. How much counter ion is there? We will not have to write. Simply we will have to write the name of the counter ion. So it is potassium. Potassium written. Then after name of the sphere here. So here zinc is the central atom and OH minus is the ligand. And for ligand OH minus, the name is hydroxy. Hydroxy here. So this is potassium. And how much? 4 hydroxyl group here. So we write tetra. Oh, no space here. Sorry, I kept here space. Oh no, we will have to keep the space because between the name of cation and anion there will be a space. So then after a space, then after tetra hydroxido, and then after here this metal atom, central metal atom is the part of the anion. This one is anion. Coordination sphere is anion because when positive potassium will go, then negative charge appears here. When 2 potassium will go, then 2 unit negative charge will appear on the coordination sphere. So here zinc is the part of anion. So then after we write zincate, it will be added there. So zincate, and find out their oxidation number. Potassium +2 plus X for zinc and +4 into -1. OH minus ion is there. That is equal to 0. Or you may also write in this manner or in that manner also. So that here 2 unit negative charge will appear when potassium will go. Then X -4 equal to -2. So X equal to +2. So here oxidation number +2. Now let's see here for this compound. Here cation is potassium, anion is coordination sphere. So on the place of aluminium, we will have to write aluminate. So how the name? Potassium. Firstly, we will have to write potassium. How much potassium? We will not have to write. So simply we will write potassium. Then after a gap, and then after here, it's oxalate ion. So we will write trioxalato. Because here no number have came in the name of the ligand. So simply tri we will write. We will not write tris. We will write tris when the number will involve in the naming of the ligand. So trioxalato, and then after aluminium, so aluminate, and then after find out the oxidation number. So 3 positive charge will go, so 3 negative charge here. X minus 3 oxalate, 1 oxalate has -2 charge. X plus 3 here, and that equal to -3. So X equal to +3. So 3 here. That was. Now let's see about this compound. Here is positive charge on the coordination sphere. So that means it is the cation. So we will not have to write cobaltate. If that be the portion of anion, then we will write cobaltate. But it's the cation. So simply we will write cobalt. So here chlorine, 2 chlorine here. So we write dichlorido. Dichlorido written. Then after here ethane 1,2-diamine. So in the name of ethane 1,2-diamine, number have came. So that's why we will write bis on the place of die. So we will write bis, a gap here and a bis, and then after inside the bracket we will write ethane what to type in written, bracket close, and then after the name of the central atom. Central atom is here cobalt, so that's why we will write cobalt and its oxidation number. So oxidation number, how to calculate? Cobalt here X, 2 chlorine, so 2 into -1. Then after ethane water diamond is a neutral molecule, that plus 0 into 2, that equal to +1. So here X equal to +3. So write here +3. Okay. Now let's see here this question. So in this compound, this is neutral molecule. So carbon monoxide is the ligand, and for carbon monoxide we write carbonyl. Carbonyl, and how much? 4. So that's why we will write tetra carbonyl, and then after nickel, and then after here how much? Oxidation number X plus 0, that equal to 0. So 0 here. So inside the bracket write 0. Okay guys, very easy. So let's see here. That's a nomenclature I did. Now you do your this one. You complete at your home. You do these questions at your home, and even though we will discuss in the next class how to write this name, and you will have to match what you did. Okay, so it's all for the today class. We will meet in the next class. Firstly, we will discuss about this question, but you must do the homework, and we will discuss here, and then after we'll proceed on the isomerism. Okay, it's all for the today class. Thank you, Team Educate.